Here's question number 4. So the evidence being referred to is this. It is colorless and transparent. So let me sketch a picture. This is always a good idea. You say, what are we talking about? We have a sample of gas in some sort of clear container, like a bottle. And we're shining some light here. And we're seeing what comes through. So imagine here's your eyeball here. We're seeing what comes through. What comes through the gas? Transparent means light does get through. Colorless means that the light that we start with is no different than the light that comes out the other side. I will use the PhET simulation to show you precisely why this colorless is important. Okay, here's the PhET simulation. You should recall this. This bubble up here shows what does the person see. Right now there's no light, so this person sees black. Now I'll turn on the light. This is white light. You can see the person says, I see white. If we pause this, white light is made up of these photons of varying colors. Red, orange, yellow, blue, green, indigo, violet, all the colors of the rainbow. The air that the photons are passing through is considered transparent. It doesn't absorb any visible photons, so the human sees all the photons that were originally produced. Now, however, we'll put in a filter. Filter has a color. Let's make it a nice green filter. Boom. The filter clearly looks green to your eye. Why? Let's now look at what happens to the photons. The photons coming into the filter are a wide variety of colors, but only the green photons pass through. Therefore, the human sees green photons only, and the person perceives the color green. The person says, that filter is green. So really, the reason why the person sees green is because the other photons, blue, red, orange, have been absorbed by the filter. So the only way a human will perceive a particular color out of white light is if certain photons are absorbed. Certain visible photons are absorbed. Let me change the filter color to be something red-orangey. So now the red-orange photons are the ones coming through. The other colors, the blue and the green. The blue and the green and the violet are absorbed. The person perceives the color because photons have been subtracted from the white light. Let me just choose 3 colors, right? Red, green, blue. And if those photons were coming through here, if the gas were colored, maybe the red doesn't make it through. Only the green and blue make it to the eyeball. So the eye, if the green and blue photons come through, then the eye will say, that's not a clear gas or clear solution. That's a colorful solution. I can see these particular colors, therefore I call this that particular color. UV is colorless, and the human eye does not detect UV. So imagine if UV photons were coming through here. Maybe they did get through, maybe they didn't, maybe they got blocked. The human eye can't tell the difference, and therefore this colorless, transparent gives us no information about ultraviolet photons. So if it's colorless, this is definitely true. True. We don't have any information about B, therefore we cannot conclude that both are true. If it happened to absorb all visible colors, then you would say that's a black gas. No light comes through. It's entirely black. No red, no green, no blue, no nothing. But surprisingly, ultraviolet could still possibly penetrate your eye wouldn't know the difference.